Hi there, this episode is an audio rip of a YouTube video. If there are any references to the screen or to the video itself, then be sure to go over to YouTube and actually check out the video, which will be the same title as this podcast. Thanks. Okay, now we're going to go on to outcome 3. Now, outcome 3 of the 2396 is just your understanding on BS 7671. You can actually see here, it's assessed in the written exam, and there's a significant quantity there of questions from the written that are basically on your knowledge of the regulations. This is why we were saying at the very beginning of this series, you need to have a good understanding on the wiring regulations before you move on to do a design course, because your design has to be taken to the regulations, and so your knowledge of the regulations has to be assessed in this course as well. And this is the outcome that will do this. So, understand BS 7671's requirements relating to installation design, so specifically about the design aspect of our BS 7671 understanding. 8 questions from the 10 question paper, so quite a large amount. So, the different areas for outcome 3. The learner can interpret the fundamental principles relating to electrical installations design. Okay, so if you remember, part 1 is scope, object and fundamental principles. So it's going to be a part of part 1 there that you're going to have to consider, and there is a section on design in that. 3.2, explain the requirements for the assessment of general characteristics. Again, that's part 3, assessment of general characteristics. So you've got to consider which areas reflect on design most effectively there. 3.3, the requirements for the protective measures for safety. And 3.4, the methods used for protective measures for safety. Now, the protective measures were introduced in chapter 41, protection against electric shock, which we'll cover in a second. Then explain the requirements for the selection and erection of equipment, part 5, followed by the requirements for initial verification, obviously not periodic, because we're talking about a design here. So what areas do the regulations say about the initial verification from a design perspective? We'll have a quick look at that. 3.7, special installations and locations. So what design considerations are needed if you're doing an installation in that includes a sauna, or includes horticultural, or you know the wiring regulations gives us support with that, but we need to consider the design component of those, and interpret information given in the appendices of BS 7671. Do we have to use the appendices during our design? Well, yes. Appendix 3, Appendix 4, Appendix 5, well, most of them really. Pretty relative, and we'll look at how some of them are used as well. So the first one, interpret the fundamental principles relating to electrical installations design. So if you go to the fundamental principles section of part 1, it will say to provide safety of persons, livestock and property against dangers and the damage which may arise from the reasonable use. So, using the installation as expected by the client. So we need to obviously assess what the client's required use for the electrical installation is. Is there going to be what's the ability of the users? Are they capable? Are they ordinary persons? Is it a school environment? Are they, is it more of an industrial environment where metal-clad equipment may be needed? Risks of mechanical impact, risks of flora, fauna, moisture. All that kind of stuff, really. How is the consumer, the client, going to use the system? Is it enough? Is the existing supply adequate? We've just looked at our maximum demand videos, and we've, in the last example, we noticed that quite easily you could equate to a maximum demand that would be over maybe what you have already. Okay, we're going to see that actually in general characteristics in a second. To provide the proper functioning of the electrical installation for the intended use. Get an understanding of how the client will use the electrical installation. 3.2. The assessment of general characteristics. So the purpose for which the installation is intended to be used, its general structure and its supplies. Okay, so if you're, for example, going to do a design for a client, they've bought a unit, let's say it's a small unit, and before in that unit was, let's say it was a You see how I make stuff as I go along. Let's say that the unit was previously a estate agent. Okay, so you have an existing consumer unit and you have just lighting and power. Now the client who's bought the building is asking you to redesign for them their installation, and they're buying the unit and they're going to put in there, I don't know, let's say it's going to be a chip shop. Now initially you're going to say to yourself, right, well, do we need all that lighting and power at the front end, where pretty much clients are just going to come in? No, we're going to rip all that out. Secondly, there's going to be a much heavier demand potentially with regards to cooking. What is there? What they're going to use to cook? Is it going to be gas? Is it going to be electric? If they're going to use electric, we need to do our demand calculation. So we must understand how the client intends on using the electrical service when we do our design. If we don't ask those questions at the design stage, we're going to mess it up. We're going to look at the external influences to which it will be exposed during reasonable use, and we need to remember that we're going to try to ascertain the use through the life of the installation. So for example, if you are installing, let's say you're going to install 2 empty units. Landlord's just bought a property, he's dividing it up into a number of units, hasn't put them up to lease yet, but he wants you to just put in a design, lighting, power. You need to let them know that this is how it's been intended to be used. Administrative purposes, for example. I used to work for an electrical training company that moved into a first floor in near London in what was an office, and basically what the guys did is they put all the training rigs and all the training bays, all these extra sockets and stuff to work on and do testing, they strapped onto the original installation. So the existing installation wasn't adequate for the person who was letting it. And this can be an issue when you're going to do some work for a landlord if it's not known at that moment in time what the use will be. But you should allow the landlord to know what the limit of the system is at that point, and it may limit their ability to let, or they may decide they want to have more potential letting and provide a larger supply. But you must understand the external influences to which it will be exposed to. If you don't know, because the property is empty, then you put that on your paperwork and it would have to be reassessed prior to a new tenancy arrangement. Compatibility of its equipment. That kind of speaks for itself, really. Ensuring that equipment is correctly selected and erected and that there's no issues of compatibility with other equipment. Maintainability. We must design a system that will allow safe, effective maintenance. Electricity work regulations. We must make sure that maintenance is achievable, that it's accessible, and that it can be carried out safely. All those considerations must be carried out at the design stage. This is where you'd have to work with other people. So if you're installing an electrical system, but there are other people installing, for example, assemblies or plant or distribution or even air handling units, they may not know, or you may not work with them close enough, and it might be that you plan on having a panel put in a position, and then they decide, well, there's some gap there, we'll put a bit of equipment adjacent to that, which then inhibits the ability to freely maintain that or safely maintain it in the future. And there are now, if you look at section 729 BS 7671 with regards to plant rooms, there are legislations about maintenance, about distance, and about passing widths of equipment and plant, so you do have to make sure you follow those as well. Recognised safety services. What are the recognised safety services? Are they existing? Are they needed for the actual design? Emergency lighting, fire, all those things. And assessment for continuity of service. So again, you may think of this immediately as a medical type of thing, where you have to have a standby IT system in it may be considered a Group 1 location, in a medical location, but also you have data, you have business. I actually remember a while ago doing some work with Marks and Spencers, and they actually have underneath all of their tills, I don't know if they still do, they did at the time, a little UPS system underneath every single till. So if there's a loss of power, the actual UPS system will kick in to allow them to complete the existing transaction. So, an assessment of the need for continuity of supply should there be a loss of the grid supply. That needs to be assessed for as well. 3.3 and 3.4 in one chunk here. You identify the requirements and the methods used for the protective measures. Now, in Chapter 41, there are 4 general protective measures. You need to remember a protective measure, and it's got the wording of protective measure here in the handbook, so that's what they're looking at. Protective measure is a combination of basic and fault protection. So basic protection was obviously protection against direct contact, as we used to remember it. So insulation barriers, placing out of reach, obstacles, enclosures. And fault protection would be an indirect contact. So you're talking about your automatic disconnection of supply, you're talking about your earthing and your bonding and things like that. So there needs to be protective measures that achieve these in some shape or form. And the general protective measures are the ones that we throw out first of all. ADS being the first one. That's the common protective measure. You'll have to consider if you need others. Some electrical equipment, for example, may not use a protective conductor. So the electrical equipment you connect may utilize double or reinforced insulation as its protective measure, similarly to things like meter tails. Meter tails, surface clipped, won't have a protective conductor within them, that if you were to hit them there would be an automatic disconnection. So they'll have the insulation and the sheath. So you'll be utilizing double or reinforced insulation for a couple of parts of your electrical installation. Electrical separation, the common example of that would be your shaver point for a piece of equipment in a bathroom type example. But have a good look in the regulations if you understand you need that. Similarly with selve or pelve, quite often we use selve or pelve these days because the electrical equipment selected by the client needs it. They come with transformers, and those transformers naturally utilize selve or pelve. But we do need to consider if there's a special location or a special installation, swim pools, bathrooms kind of environments, where the regulations will say, no, you actually now need to use selve or pelve, and you need to make sure that the voltage is limited to no more than 12 volts or 24 volts. So we need to be aware of these protective measures. But the one that we'll use first of all is ADS, and that is just effective selection of an appropriate conductor size and earthing cable that will achieve a high enough fault current to achieve quick enough disconnection time. The ZSs, if you will. Okay, but we need to identify at the design stage how we're going to achieve sufficient protection, and we'll use the protective measures as tools to determine that. 3.5. Explain the requirements for the selection and erection of equipment in electrical installations. You have to just become familiar with the whole content of Part 5, the common rules. You must make sure the equipment that you select is installed to manufacturer's instructions, is an appropriate kite mark or CE mark, and you get it from a reputable vendor and things like that. Always follow the manufacturer's instructions. Go through Part 5, get some familiarity. Do remember though, in the assessment in the 2396 you have the book with you. It's not a memory exercise. What you need to do is have familiarity with the document. If you have familiarity with the book, you've got all the time in the world. I believe the exam was like 3 hours long when I sat it. And I just kept writing. I literally filled the paper up. I got a distinction, so I guess I did okay. But you have all the time to use. And so just get familiar with the layout and how to identify what it's looking for. Similarly with protection, isolation, switching, earthing arrangements, other equipment and safety services. Bit of familiarity, okay? 3.6. With initial verification, again, familiarise yourself with Chapter 61. It's very, very small. It'll tell you about things like inspection. You must carry out the initial verification during and on completion of the electrical installation. So when you're doing your design, you should make sure that obviously there are points or pivotal points for the constructor to have effective initial verification carried out. It might be that the person doing construction, doing the install, has the skill, or is going to be the person carrying out the initial verification. That's fine, but what you probably need to do from a design perspective is install or apply methods that support initial verification, such as access equipment, such as prioritizing the design or the install at points when initial verification can then be followed up before people then cover things up or put floorboards down and make the ability to inspect it impossible. So the designer needs to be aware of this and needs to imply initial verification at pivotal points of the installation stage. Similarly with testing, we need to determine that the testing must be carried out in sequence. There is a sequence of tests with initial verifications, and we've got to make sure that those are actually achievable. For example, if I was carrying out an installation of I don't know, 30 to 40 downlights or spotlights, I probably would design a method of connection such as these maintenance-free connections. There's a good Hager one that goes through a spotlight position, or the Wagos or whatever. But a method of connection that will be easy to terminate the mains cabling, but then before you introduce the luminaire, the transformer of 12 volt, or the equipment itself, whatever it is, the ability to put the mains in, and before you connect the equipment, carry out that installation resistance test between live conductors, because technically that should not be not applicable or limitation on an initial verification of a brand new installation. Because with regards to periodics, we say, okay, yeah, you know, that's a limb, because we're not going to go and take out all of this electrical equipment, because that's going to be dismantling, that's going to create further disruption and potential damage, and it's going to shorten the life of the equipment. Fine. But from an initial verification perspective, there should be a recognition that those live conductors have been installed, and before we actually then introduce electrical equipment on the end of them, there needs to be a test carried out between line and neutral, or between live and lines respectively. So this is up to a designer to implicate these processes. You're just thinking, no, that doesn't happen. Probably doesn't happen, because quite often the designer has no freaking clue. But you know, that's what we need from BS7671. That's the ideology we're supposed to have on the initial verification with BS7671 and design. 3.7 special installations and locations. Again, it's familiarity. The special locations will give you restrictions, IP requirements, zonal concepts, the protective measures. It will say you must only use this protective measure. Okay. I'm not going to go through what they all are, because again, that's a 7671 training, but you should be able to quickly go, oh, this design question mentions a sauna, I'll go to 703 and I'll look in there, and the external influence is this, and the pay rating is it should be easy to do. If it's not, then you need to think about your knowledge of the 7671 and relearn that a bit, because this should be a walk in the park. This kind of area. Okay. Similarly with the appendices, quite a lot of times it will pick up. But if you remember from your regulations course, a question may say, oh, you know, you've got an ambient temperature of 40 degrees, 70 degree thermoplastic. What rating factor? And you'll go, oh, that one. In the 2396 exam, it might actually come up. Remember, there are 10 questions, but there may be large structured questions, and it might give you a scenario where it will say, oh, you have 3 other circuits grouped collectively, surface clipped, bunched together, and you have a 3036 semi-enclosed reliable fuse, and the load is likely to need overload protection. Oh, and there's an ambient temperature of 25 degrees, and you're going to bury it in the ground at 0.5 meters deep. It might combine some of that crap together. Not a problem. You just take each one out, you find the factors, and you do the math, and you combine it, and then you come out with your cable size. I will be doing a couple of videos just to play with that. It's all very good to practice, because that way, when you come to doing this, it becomes basically a thoughtless process. It's just familiarity. So many people rely on software and stuff, and one of the things I end up doing is actually kind of proof checking some software, because they're only as clever as the people who use them, and they're not great, some of them. But get familiar with the regulations and you won't have a problem. It really isn't that hard. Similarly with things like your external influences, your time current characteristic curves. It's just familiarity. Alright. That's outcome 3. Again, we can see that is a huge amount of the written exam. But it's in the book. It's in a book that we should know, and it's in a book that we should have. This is very important, this bit. If when you approached your 17th edition exam, the trainer was like, here's a question paper, here's a question paper, here's a question paper. Unfortunately, that's the case with many, and hopefully that's not happened for you. But if that has, what you need to now say to yourself is, how have you actually progressed your ability to apply regulations? This is the problem. The way City and Guilds have the 2382 course assessed is just simply a multiple choice 60 question piece of crap, which basically says, I'll find this and then find that and then find that. It doesn't combine anything. It doesn't give you a scenario that says you have this circumstance, you have this number of external influences, and you have these characteristics come up. It doesn't combine any parts of the book. And if you haven't carried that out before, if you've not played with that, I suggest that you start doing that. I'm going to do some videos that kind of encourage that that play anyway, because it is important to make the regs book a tool. So many people just think of it as this barrier, as this obstacle to hop over, and unfortunately that's the way the training companies and the industry has used it, and it is an absolute shame. Everyone should have a good understanding on the regs, and everyone should have the ability to use it, because that's why it's there. If you haven't used it that much, then consider using it. We can become very complacent with our work. We can, we can just do the same thing day in, day out. But one day something new might crop up, and we may just need to be able to go to that regs book just to get that extra bit of assurance with our design that we know we have the backing of the regulations. And if we have the backing of the regulations, then fundamentally we should have the backing of the legislations, because they kind of push to these. Alright guys, familiarity with the regulations. If you at this point think, oh, I'm not too sure of the regs, I would suggest that you kind of think about studying the regs for a bit, or going on to a couple of videos that I'm going to be uploading sooner or later. If you're looking at this playlist like the day it's uploaded, it won't be up there yet, but they'll be up there very soon, where I literally just play with the regs. We'll throw some scenarios in, and we'll just see how the regulations work. The regulations need to be something that you kind of just look at and just you know that you can use it, and you know that you have no problem with it. And my job here is to kind of help you get there if you don't feel like you're there yet. Alright guys, I'm going to upload this at this point. We'll do outcome 4 later today. Hopefully I'll load it at the same, probably upload it at the same time. And I've just noticed also that the City and Guilds handbook and the qualification book have crossed over outcomes 4, 5 and 6. So I'll probably just do them in the order that the assessment says they should be done, so that the information is there in that pattern. But yeah, that's outcome 3. It's again, regulation familiarity shouldn't be an issue. Yeah, we'll leave it there. Cheers.